In this video, we're going to look at some more examples of finding the domain and range of inverse functions. So example 3, part F, we have f of x equals 1 over x and then minus 7. So let's make this y equals 1 over x minus 7. Switch our x and y. We get x equals 1 over y and minus 7. So we got this minus 7 hanging out on the right-hand side. We want to add 7 to both sides to get x plus 7 equals 1 over y. And I don't want to work with fractions any more than the next person, so if we multiply both sides of our equation by this denominator y, we'll get y times x plus 7 in parentheses equals 1. Now, if we distribute this y to both terms, we'll end up with xy plus 7y equals 1, and that's not really going to help us get to having y by itself. So rather than do that, since we already have the red y outside parentheses, and we have red y times the expression x plus 7, if we divide both sides by x plus 7, that'll get the red y all by itself. So we have y equals 1 over x plus 7, which is our inverse function for 1 over x and then minus 7. All right, so for this one, find the domain of our original function. Our original function has an x in the denominator, and that means that our original function, the domain is x cannot equal 0, but it can equal anything else. So our original function's domain is all real numbers except for 0. So we can just write it as x not equal to 0. That's going to match the range of our inverse function. So the range of our inverse function is all real numbers for y, except y can't equal 0. So again, these two values, these two inequalities are going to be the same, both not equal to 0. We're just going to switch it from x to y when going from the domain column to the range column. Now, if we look at our inverse function, the domain of our inverse function, we have x plus 7 in the denominator, and x plus 7 is not allowed to equal 0, which means x is not allowed to equal negative 7. So our domain of our inverse function says that x is not allowed to equal negative 7. That's going to match the range of our original function. So our original function is all real numbers for y except negative 7. So in our original function, we'll get back any number in return except negative 7. All right, part G, we have f of x equals 3 over 2x plus 5. This is actually one of the ones we looked at in the domain and range video. So now we'll see how we can use inverse functions to figure out the domain and range of the original function as well. So we'll make this y equals 3 over 2x plus 5, and switching our x and y, we get x equals 3 over 2y plus 5. And if we multiply both sides by the denominator 2y plus 5, it'll get rid of our fraction, and we get x times, in parentheses, 2y plus 5 equals 3. Now in this example, the y is inside the parentheses, and the last example was outside the parentheses. So since the y is inside parentheses, if we divide both sides by x, that'll get rid of the x that's outside of the parentheses. So dividing both sides by x, we get 2y plus 5 equals 3 over x. So to get the red y by itself, we're going to subtract 5 from both sides. And when we do that, we get 2 times y equals 3 over x minus 5. So bringing that over to have more space here, 2 times y equals 3 over x minus 5. Our last step to get y by itself is to divide everything on both sides by 2. Now, normally that'd be okay, and we can still do that. However, with this 3 over x fraction here, rather than divide both sides by 2, instead, we're going to do an equivalent of dividing both sides by 2, and that's multiplying both sides by a half. So if we multiply the right side by a half, each term is going to get multiplied by a half. So 3 over x times 1 over 2, 3 over x times 1 over 2 gives us 3 over 2x. And negative 5 times a half is negative 5 halves. So our inverse function is 3 over 2x minus 5 halves. So now with our original function and its inverse, our original function's domain, we said earlier in our last section on domain and range that x cannot equal negative 2.5 or negative 5 halves. That's also going to match the output values of the inverse function. So for our inverse function, this 3 over 2x minus 5 halves, Our range is y is all real numbers except -5/2. So we can just abbreviate that as y not equal to -5/2. Now, for our inverse functions domain, notice in our inverse function we have a 2x in the denominator for this first fraction. So 2x is not allowed to equal 0, which means x is not allowed to equal 0 for our inverse functions domain. We're going to copy that and paste it into our original function's range and just change the x to a y. So in the domain and range section, we looked at the graph and said that, well, you can divide 3 by the 2x plus 5. You're never going to get a 0 in return because 3 divided by any number will never give you 0. Here, using the inverse function approach, we can find the domain of our inverse function and copy that value into the range of our original. So now you have that option when finding domains and ranges. And if it's a little bit tough to find the range of the original function, maybe find the inverse and then state the domain of the inverse and copy that to the range of the original. So you have that option. All right, that about does it for this video. Thanks for watching. I'll see you next time.